Now as we go on, we want to learn addition with renaming. Now this is really cool, and what is important here is as we go through it, they need to remember that 10 ones is the same as 1 10, and 10 tens is the same as 100. Okay, this is the important thing that they need to remember. So now what they will see is, and this is where all the time that they have spent breaking down their bundles and taking a bundle of 100 and breaking into bundles of 10 tens, or taking bundles of 10 tens and putting them together into a bundle of 100 comes to your help, because this really describes how the long addition algorithm works. So now you can see that they are adding, and this is important. I mean, you should not, the way this is being stated right over here is a very important way of stating it, and one should not underemphasize this idea. 6 ones plus 8 ones become 14 ones. And 14 ones, you can break them up. Remember, we've done number bonds. 14 ones can be broken up into 1 10 and 4 ones. So what we are going to do is, since this is the 4 ones place, so this is the ones place, we're going to keep the 4 ones here, and the 1 10 right over here, color coded, which is right the same color code over here, the 1 10 is going to be kept for safekeeping. Now we also have 3 tens and 1 10 and plus 2 tens, right? So we have 3 tens and 2 tens that make 5 tens, but we also had a 10 for safekeeping. So it's 3 tens plus 2 tens plus 1 10, which will make 6 tens, and this is because of the 6 tens here. Okay, and then you should relate the algorithm that, which is a very abstract algorithm that we do, which is 36 plus 28, and the columns are line, and then we have 6 and 8 is 14 ones, and we have 4 ones over here, and the 1 10 it comes right over here as a reminder, and this, then you have 3 tens plus 2 tens is 1 10, and 3 tens plus 2 tens is 5 tens, and 5 tens plus 1 10 is 6 tens. So you get the answer 6 tens and 4 ones. Okay, so this is addition with renaming. We'd also do subtraction with renaming, and please remember it is really renaming because we are renaming things. So again, you have this 62 minus 43. So now, I mean, you can start talking to children and say you have 6 tens and 2 ones, and now you want to eat 3 ones. Well, you can't eat 3 ones. So what you have to do is that you take a 10. So you had 6 tens, and you have to take a 10. So this is a 10 right over here, and this 10 is broken by the bank into 10 ones, right? So now you can think of this is a very important idea, that now you're thinking about 6 tens and 2 ones as 5 tens and 12 ones, and this is what is happening. So please note that when you have 62 minus 43, what we do is, so this is what this is saying, that 6 tens and 2 ones we want to think of as 5 tens and 12 ones. And please note this is what we're going to do, because we're going to, what we do over here is really, this is the act of thinking of 6 tens and 2 ones as 5 tens and 12 ones, and that's what we're doing over here, right? And now from 12 ones we can eat 3 ones to be left with 9 ones, and we have 5 tens, and we can eat away 4 tens to be left with 1 10, and the answer is 19. But it's very important to understand what are we doing, okay, and how are we breaking up the 6 tens and 2 ones into 5 tens and 12 ones, and this should be repeated over and over again with pictures and showing how pictures correspond to the more abstract way of writing the same thing down so that it is absolutely clear that there's no mystery behind the correctness of this algorithm. Okay, so now this whole thing gets repeated with more complex numbers. So now please note, if you're trying to subtract 729 and minus 64, so we can clearly from 9 ones, from 9 ones we can clearly eat away 4 ones, and we're going to be left with 5 ones. That's perfectly clear. But now please note, we only have 2 10s and we want to eat away 6 10s. That's not possible. So what we're going to do is, so we're going to reinterpret, and that's what is important to understand, that we want to reinterpret 700s and 2 10s, because that's what we had. We're going to reinterpret it as 600s and 12 10s. And that's what we are going to do when we subtract. We'll have 729 minus 64. We certainly could subtract 4 from 9, but now this is where the magic is coming in. We're going to reinterpret this as 700s and 2 10s is reinterpreted as 600s and 12 10s, and then you get your answer, which is 12 minus 6 is 6, because if you have 12 10s and you eat away 6 10s, we're going to be left with 6 10s. And if you don't do anything to your hundreds, the 600s are going to stay as is. But it's important to be able to understand this very simple but important idea of what we are doing and relate it to this picture on the left, and how we are breaking up the 100 into 10 10s. Okay, now this is a nice interesting problem that we can think about. It is 300 minus 28, and this is kind of a fun problem to think about. So you have 300s and you want to eat away 28 out of them. Well, you have 0 1s and you want to eat away 8 1s. Well, you can't do that. So what are you going to do? Well, you look to your 10s, friends, but your 10s, there are no 10s also. So then you look forward and you find there are 300s. So now what you're going to do is you're going to take 300s and reinterpret them as 200s and 10 10s. But the problem is that and that's the first part. So I'm going to reinterpret this as 300s, as 200s and 10 10s. But that doesn't also work. So now I'm going to reinterpret this as 200s. This stays. 9 10s and 10 1s. So this is what I'm going to do. I'm going to convert this into a 9, and this actually is going to cross out this 0, and I'm going to have 10 1s. So now I have 10 1s minus 8 1s, which is going to be equal to 2 1s. I have 9 10s minus 2 10s, which is going to be 7 10s, and 200s minus 0 hundreds, which is going to be 200s. So the answer will be 272. Please note that the book is writing it in a very beautiful way, and children sometimes write it in a very large, using very large font, and sometimes it's very hard for the child when they're revising a problem to see what mistake they've made, to follow through, or to understand what they've done. So what I would really suggest is that you really want to do something like, as the book is doing, 300 minus 28. What I would do is I would cancel off the 3, write it 2, then I have 10 10s, and I'm going to reinterpret the 10 10s as 9 1s and 10 1s, And now if 10 ones minus 8 ones, which is going to be 2 ones, and 9 minus 9 tens minus 2 tens, which is going to be 7 tens, and 2 hundreds comes in. Okay, so I would try to figure out a way of writing this subtraction algorithm in a way that will help the child when they are taking an exam or trying to do a problem and they want to revise whether they've made a mistake or not. It's important for them to be able to understand the calculation that they've done earlier so that they can point out a mistake or be sure that they have not made any mistake. So writing cleanly and neatly when you're rewriting the minuend is very important. Okay, thank you.